What's up? How are you doing today? This is Yuki. I'm fine. So I'm going to solve the LeetCode question today again. So today's question is this one. I'm going to copy and paste here, and then I'm going to make it title. So the question is merge two solid lists 21 in LeetCode. I'm going to take a look at the question. So I'm going to copy and paste this one to there. So the question is merge two solid linked lists and then return it as a solid list. Okay, so we're gonna have two linked lists and then just make one linked list which is solid, and the list should be made by slicing together the nodes of the first two lists. So we are looking at the first two heads of the each two linked lists and then just compare and then just put in smaller first and then go to the next and then smaller first, like this. So slicing together the given two linked lists and then eventually we making one linked list which is solid. We can take a look at the example. So example, make a subtitle, and then we have this example and copy and paste here. So we have two linked lists and then we have one output linked list, and then this is sorted as is said here, and then first we come in together one and one, and then we put it one in one, and if we have 2 and 3, because 2 is smaller than 3, 2 comes first and then next 3, and then 4 and put 4. Yeah, so this is sorted. And then okay, what we can see from this example is when the number is equal to each other, in the output we don't know which is first, because eventually basically we cannot identify which is we belong to L1 or L2, but that's the thing I can find from the example. I can go to the next example. So next example is this. I made a mistake, and then bracket. So the second example is if two linked lists are empty. In that case, we have to output the empty list. Okay, sure. So we have to make that kind of implementation. And then the third example is if either linked list is non-empty but the other is empty, we have to produce non-empty one. Okay. So okay, that's the example. So we have to produce. Okay, this example, sure. Do we have any constraints? Yes, we have. So I'm gonna type constraints, and then we have several constraints. I'm gonna copy and paste to here, and then I'm gonna make a bullet point. So the number of nodes in both lists is in the range of 0 to 50. So the length of the linked list from 0 to 50. So we could have empty or 50. 50 is not that big compared to the other questions in the linked list in LeetCode. And then the value, node.value could be -100 to 100. The question is, what's this? So we actually have a code given to this question. So I'm gonna say code given code. We have this kind of input. So we are given list node class, and then this node.val I can think of, that's the object of list node, and then which is accessing the val property, and val contain the actual number of the node in linked list, which could be negative. Okay. And the third constraint is both L1 and L2 are sorted in non-descending order. So output is going to be ascending sorted order, but our input is also already sorted in non-descending order. Okay, interesting. And then in the given code, we actually have this class that we have to implement in this question. So we're going to make a solution class, and that has one function merge two lists, and then we have two arguments L1, which is the list node, L2 is also list node, and then we are producing list node as well. Okay, so now we can go to think of how to make this algorithm. So what we have to do is given input, we give an input, but there is a case that there is no input. So to the argument, to the argument, check the emptiness. So if L1 is empty, we just return L2. And we can think about the other case, which is if L2 is empty, so we return L2. L1. Okay. Do I cover everything? So my question is, if both are empty, what's going to happen to this if statement? So I can see that if both are empty, L1 is empty, and then we returning L2. But in this case, L2 is empty. So even though both are empty, these two if statements cover this both are empty case. So I can say that these two if statements are enough for emptiness check. So now we can I can go to the actual numbers case when we have actual numbers. So when we have actual numbers, we have to make sorted ascending order. So we have slicing together. So we have L1 and L2, and then if L1 is smaller than L2, L1 goes first. Okay, and then if L2 is smaller than L1, L2 goes first. So far so good. So far good. And then what we can see from here is that we only checking the greater than and also less than, but it's not checking if those are equal. So if L1 is equal to L2, we already seen in the example, we don't care about the order, so we don't care about the order. So handle this in either above, maybe you have my face around here so you cannot see, either above if statement, because we really don't care. So maybe we really don't care, so maybe we can say smaller than or equal to. Okay, we can do that. And then from here we finish the first element decisions, and then we have to go to the next decisions. But basically we just compare, but next time we compare again. So we are going to iterate, but the question is how to iterate. So L1 goes first, so the next comparison is if L1 goes first, compare L1 next and L2 current. And that's the same for the other case, L2. If L2 goes first, compare L1 current and L2 next. Okay, so when we compare, we having list node and list node, and the L1 is also list node. And then the next comparison is also, this is also list node, and the L2 is also list node. And then we just output something bigger, something smaller, and this is also output something smaller. Typo here, but this something is also a list node. So basically, what's happening here is we implemented this merge to list methods to argument list node and output in the list node. So at the first moment, we can use this function, but the second iteration, we can also use the same methods because the argument and also output is also the same. So basically, in the iteration, we can reuse the same function, which is recursion. We can do recursion. So we do this, recursion, and then sometime in the future, L1 is going to be empty, and we return L2, and then this function going to stop. Or L2 going to be empty first, and then we return L1, and this iteration goes to N. Okay. Going to N. And then goes out of this function, and then how to stop? Stop. So until the empty, when empty, the same function is going to stop, and then we just return the first list node. So the how to stop this is stopped by empty if, and then we just return. This is at the end. At the end, the return, the function returns the first list node. That's okay because first node is already, so goes first, compare one and up to smaller, and then this is in connect this to L1 dot next. So here when we return the first list node, and list node is already have the next is also connected to the list node and then connected to the list node. So if we continue these iterations, we already have a linked list. So when we return the head of the linked list, we can return entire sequence of list node. So I think I cover everything. So I think I can go to the implementation. So I'm going to go to the implementation. Before that, I'm going to take a break. So implementation is we have to implement this class. I'm going to copy and paste here. No, I'm going to copy and paste here, but I don't have optional, so from typing import optional, okay. And then we're going to implement this algorithm. So the first check is we have to check the empty. So if L1 is the example showing looks like something Python empty list, but we don't have empty because the argument is optional of list node. So we could have link list node or none. That's the definition of optional. So it's not empty, technically it's none is coming. So when none is coming, we just return L2. And then else if L2 is none, we are going to return L1. And then these are just two if statements are fine to cover all the cases, like both are empty also is inside the if statement as we've already seen. And then from here we can actually compare the numbers to make sorted order. So if L1.val, so we need to access the numbers. We can access the number by, because list node has a val property, so we can use .val. and then if this is smaller than L2 dot val. So in this case, L1 is smaller, so L1 goes first. So L1 goes first, but L1 goes first, and then L1's next. We are connecting L1 next to something. Going to be, we have to compare again. So L1's next, or L2 current thing. And then, as we've seen, we want to continue this until we don't have any more list nodes. So we have to do the iteration, and we want to do recursion. And we are going to use the same function. We can do that because this is list node, this is list node, this is also list node. So we can use the same function. So merge two lists. We can do this, and then but we are accessing the function inside the class, so I have to say self. I can take a look at the another case. So else if. So in this case, L2 is smaller than L1.val. So in this case, L2 goes first. And then we are going to do the same, merge two lists. L1 or L2 next. Okay. So if we do this, so the first if statement, L1 goes to first, okay, that's fine. And then we have to decide the next one, which is going to be L1's next or L2 current, and then goes to the same function and come here, and then suppose we still have the number here, and then we come into this if statement again, and then so the if again, if L1 is smaller than L2, L1 goes to next to the we are going to compare again, and then we just continue this, and then eventually either list is going to be empty, and then if the L1 goes to empty first, we can just return L2, and even though L2 is bigger than length 1, that's fine because L2 is already sorted by the constraint, which is saying it's already sorted in non-descending order, so we can just directly connect or the entire rest of the L2. So eventually this function is going to be n, and that's connected here, and then eventually we have to return this optional list node. So from here we can just say return L1, and that's the same for this statement. We just return L2. But if we do this, we haven't seen this L1 is equal to L2 case, and we don't care about the order, so we just put the second one. So we just say this is smaller than or equal to. That's fine because we don't care about the order. So basically that's it for the implementation. And then now we can see time complexity. So this is going to be so let m be the length of L1. Let m the length L1, and then m the length L2. So because we comparing one goes first and then compare again, one goes first. So basically we have to go through each element of each list node. So the time complexity is O of m plus n. And the space complexity is going to be, so we are making additional list node and then we return it. And then this list node has just the summation of two list nodes. So this is also summation. So O of why being such big? Why such big, man? I don't know how to make it smaller. Maybe I can just type here. So that's also O n plus n, because this is just the summation of two lists. So at this moment, I think I can copy and paste this implementation to here, and then before that, I just read it again, whether that's fine. There's no, oh, it's none. None. If this is smaller than S2, L1 can go first. And then, yeah, I think should be fine. Yeah, I'm gonna submit it. Yeah, so it worked. So, so in this case, in this question, we've seen the question making the list using the list node. We solved it by using the recursion by using the same function over and over again. So that's it for today. Thanks for watching.